Hello, welcome to the demo for the Y-connected transformer shop job. To this point, we have explored a little bit about how transformers work, how to phase them out, what it means for coil polarity and how to identify that, as well as overall transformer functions in a Y connection or a delta connection. So what do we know about a Y connection? We know that line voltage is greater than phase voltage by the square root of 3, or 1.732. This is measured from line 1 to line 2, line 2 to line 3, line 1 to line 3 on the primary side, and on the secondary side we call it phase A, phase B, and phase C, so forth and so on. So any one of the measurements that you would take from one phase, be it A to B, will be 208 volts, while any of the phases to ground or neutral, or that common point, would be 120 volts. Alright, continuing on with the Y connection and what we should know about it to this point. Line and phase current are the same. So in other words, if you put your clamp-on ammeter on one of the lines for a Y connection, it should be exactly the same as the phase. This is because the load is typically connected in series back to ground, or the neutral point, or the common point, and this is giving us essentially one path for current to flow. If we were able to do this as a demo in class, I would show you that removing the neutral or the ground connection would actually cause an imbalance in the phases, and you might see a slightly different current based on the resistance in that circuit. But for theory purposes, for explanation purposes, we say that we are in series with the load back to ground or back to source. That's why we have one path for current to flow. Here you can see that a little bit better. So if I have light bulbs out connected on the end, then I come out of phase A through a light bulb and then back into neutral, okay, there's only one path for that current to flow no matter where we follow it back to. Once we get to the transformer, we see the X1 to X3, okay, X2 to X4, so forth and so on both sides. So we have a Y-connected system on the primary, and we also have a Y-connected system on the secondary. What does that mean for us? That means that we're going to have the exact same primary and secondary voltage readings. So on the primary side, since our building is fed with a Y connection, 120/208, we would see 120 volts from line 1 to the neutral point, and we would see 208 volts from line 1 to line 2. On the secondary side, we form that neutral point again. We would bring this neutral connection back to a ground to give us a good ground reference. Once we've done that, we are then free to connect the light bulbs with a light bank and measure our currents accordingly. A couple of more explanations. So the line-to-line voltage reading should be equal to 208 volts. The line to neutral should be to 120 volts. These are the same readings you should have done in the light bulb shop job previously. The voltage is supplied to the transformer bank and used out on the secondary side, or also known as the load side. This is used to provide isolation to the secondary side. Why do we do that? Isolation allows us to suppress transient voltages as well as voltage or current spikes. For the current, as we've already mentioned once before, it should be the same from the primary to the secondary because everything is exactly the same as far as connections go. You will see a slightly lower current reading on the primary side for this one, in most cases due to transformer losses. But they should both be equal to the same volt amps at all times. So in some cases what you'll notice is if the voltage drops a little bit, you may see more current flow or vice versa, so that the volt amp calculation comes out the same. Alright, power in equals power out of a transformer. So the volt amps calculated on each side of a transformer should always match, or be really, really close. This is done by using Ohm's law to measure, using Ohm's law with measurements that you might have taken, or using Ohm's law to calculate the values in total. Alright, in order to find the current, for example, using the formula P equals I times E, you could take a 100-watt light bulb, divide it by 120 volts, and you should see approximately 1.2 amps at that voltage. Alright, hopefully that clears things up for you a little bit. Thank you for watching.